I love the smell of coffee in the morning. The warmth, the flavor, the aroma prepare me for the day ahead. I love the ritual, especially the part where I add creamer to my coffee. And I love watching the flow patterns that it makes. It's mesmerizing just to watch the coffee change color, but more so to observe the cream-colored flow structures form in the darkness. The way the eddies dance around and mingle with each other until the coffee has settled. I go as far as saying it's my favorite part of the day. So the flow patterns that I just described are actually all around us. We just can't see them. I move the air every time I speak, every time I move. These intricate patterns are all around us in the air. They're even all around us in water. Every time we go to wash our hands, we see the water form patterns as it splashes around and flows out of the faucet. These complex eddy patterns are what we call turbulence. You will no doubt be familiar with how turbulence feels if you've ever flown on a plane. The same eddy patterns exist all across the oceans of the planet and the global atmosphere and every other planet. And these patterns can even be seen in the shapes of galaxies. Turbulence is everywhere. We cannot escape it. I cannot escape it. So growing up in a South Asian family, it was drilled into me, when I grow up, I have a small selection of careers to choose from. Medical doctor, engineer, lawyer, and accountant. So 3 was definitely out, right? I suck with words, and more importantly, I suck at debates. How will I ever convict criminals if I can't even fight the case? 4 was also out. I don't have the analytical brain of my brother. I suck at reading legislation, tax laws using Excel, and I'm sorry, I don't want to learn. So it left me with 1 and 2. So my dad is a cardiologist. So growing up, I learned a lot about the heart. I love learning about the mechanical nature of the body, but the heart in particular, the way the atriums opened up to let the blood in and the ventricles pump the pressurized blood around the body. I was unsure about the choice between 1 and 2. So at the age of 16, I asked my dad, can I shadow you at the hospital for 1 week? He was more than happy to oblige. So one of the things that my dad does is he performs angiograms. This involves sending a catheter through the femoral artery in the inner thigh all the way up to the heart. And this is the procedure my dad performs at the end of every single week. So for me, this was going to be my treat. I was going to sit outside the operating theater and observe through the window. And outside the theater, the computer crashed. And I managed to fix it before the IT department got there. I have a way with tech. So when the monitor came back on, I could see the x-ray of the heart, and I loved watching the rhythmic pumping of it. I could see the blood rush in and be squeezed out. I could see all the vortices and eddies formed in the blood. It was fascinating to watch. I remember being in a trance, just watching the heart do its thing. And as I sat there, zoned in on the monitor, I remember seeing blood fly out everywhere in the background. So, you know, in horror movies, when you see someone gets cut and the blood just flies everywhere, you think that's just in a movie, right? Nope. That's exactly how it flies out of your body when you cut a vital artery. The same way water flows out of a faucet with pretty patterns forming in the splashes. One of the nurses cut the artery wrong and the blood shot out. I mean, it is flying. It's in this great trajectory across the room and the nurses are panicking. The patient's heart rate is rising. My dad immediately springs to action. He starts commanding the theater, instructing the nurses on exactly how to act and what to do. Heroic for sure. I can't say I was all too fascinated by the way the blood flew out of the body. Otherwise, I would be a serial killer right now. But I was surprised. It made me think about how blood is pumped all around the blood vessels that we all have inside of us. I remember that drive home that day, my dad did not make eye contact with me at all. He somberly stated, "You're not going to be a doctor, are you?" There goes number 1. I guess I'm left with number 2. So I left home to study aerospace engineering at the University of Southampton, but I wasn't satisfied with doing a regular engineer's job at the end of my degree. I wanted my job to be something cool. So I got a job as an F1 race car designer. And as far as chat-up lines go for nerds, being an F1 race car designer was right up there with saying, hey, I'm a rocket scientist. So I worked with my colleagues to design faster race cars for races all around the world. And I can still feel the thrill and excitement in fighting for championship points with my colleagues. I remember spending hours and hours analyzing fluid flow around the car and realizing actually I was more interested in the twirls and wisps of air flying past the car. The way the vortices meandered around the wheels and caressed the wings. Again, I remember being in this trance, watching the dance of eddies around the car. So I decided to return to school to obtain a master's degree. But I wasn't so sure about returning as a race car designer. The class I enjoyed the most during my master's was turbulence modeling. I just couldn't get enough of it. I loved it. I loved learning about the different ways people tackled the problem of describing turbulence. And I love the intricacy of the mathematics behind it all. And hearing Richard Feynman describe it as the last unsolved mystery in classical physics lit a fire in me. I mean, this was it. I had found my calling. I figured I would try and work on the problem. So I decided to apply for a PhD that revolved around solving the governing equations of motion. And I used to spend hours and hours reading up on scientists of the past, working on and developing ideas to further our collective understanding of this phenomenon. I read about von Karman's vortex patterns, Liepmann's work on flow and stability, Dimitrakis' work on turbulent transport and mixing, and the work of McKeon on the fundamental workings of wall turbulence. They were all pushing the boundary of our collective knowledge. But that last one really grabbed me because it explored the mathematical underpinnings of wall turbulence and what really made it tick. So I sent a short email to Professor McKeon at Caltech expressing my interest in her work and potentially having the chance to work with her. Her response was, thanks, but I don't have the funding. Maybe another time. So I focused on my thesis, which was on solving the equations and how they helped me understand the clockwork behind turbulence. And towards the end of my PhD, I started looking for jobs. I interviewed at a bunch of hedge funds, consulting companies, and think tanks. I ended up getting a job offer as a consultant working in the city of London. And I would get to travel all over the world, advising large corporations, making big important deals, dining in fancy restaurants, laughing with a cigar in my mouth, super glamorous job for sure. All I had to do was finish my PhD. And finish I did. I passed my Viva and received my doctorate on May 10th, 2018. Dad, I became a doctor. I felt great. I had a job lined up in a consulting firm. I was about to sign the contract when suddenly my phone pinged. It was an email from Professor McKeon asking me when I'm available for a Skype call. My name is Mohammed Ahmed. And I work as a postdoc at Caltech in the McKeon group, and I model turbulence in the oceans and atmosphere. I turned down that consulting job, and I moved to the US to pursue my dream of being a scientist, pushing the boundaries of human knowledge. And now I walk past pictures of von Karman, Liepmann, Dimitrakis, and Professor McKeon every single morning as I make my coffee.